Assistant Professor, Department of EEE, DBSIT, KAVALI. So, in this present semester, I am going to discuss or I am going to teach the subject is Electrical Machines 3. So, in Electrical Machines 3, already you studied about Electrical Machines 1 and Electrical Machines 2 subjects. So, in those two subjects, you studied about DC machines, and in the Electrical Machines 3 subject, we are going to study the AC machines. Okay. So, our subject name is Electrical Machines 3. So, in this subject, we have 5 chapters. We are going to cover 5 chapters. In those 5 chapters, first chapter is Synchronous Generators. Second chapter is Voltage Regulation Methods of Synchronous Generator. And third chapter is Parallel Operation of Synchronous Generators. And fourth chapter is Synchronous Motors. Fifth chapter is Single Phase Motors and Special Motors. So these are the 5 chapters we are going to cover in this subject. So at present I am going to cover the first chapter, that is Synchronous Generators. So Synchronous Generators, this is the first chapter in our Electrical Machines 3 subject. So in this chapter we are going to cover different types of topics. In those topics, first topic is introduction. Second topic is principal and constructional features of salient pole and round rotor machines. And third topic is armature windings. Here we are going to discuss different types of armature windings. Those are concentrated windings, distributed windings, integral slot windings and fractional slot windings. And we are going to discuss the different factors. Those are pitch factor, distribution factor and winding factors. Okay. And we are going to discuss EMF equation of the synchronous generator and harmonics in generated EMF. And in those harmonics we have two harmonics, that is space harmonics and slot harmonics. And we are going to discuss elimination of harmonics concept, and after that armature reaction, and after that synchronous reactance and impedances, and after that we are going to discuss load characteristics, and lastly we are going to discuss phasor diagram. And now in this class I am going to discuss the introduction part of electrical machines. So coming to the introduction topic, so here we have introduction, that is, so we are already know that electricity does not occur naturally. So we are already aware about this one. So electricity does not occur naturally in the usable form. Okay, and it is also cannot be stored in usefully large quantities. Okay, so we are not going to store the electricity in a large quantities. So therefore it must be generated continuously. So we are going to generate the electricity continuous manner to meet the demand at all times. At all times, because so this electrical power generation is the main concept to use the generated electrical power. So that's why we have to generate the electrical power in a continuously manner. So why? Because to meet the demand at all times. So that's why we are going to generate, or we are generating the electrical power in a continuously manner. So here an efficient and convenient way to generate electrical power by using the generator. So that is what is meant by generator. Generator is an electrical machine which is used to convert the mechanical power into electrical power. So that is known as a generator. So here we are using synchronous machine. Okay, here we are using synchronous machine. That's why a synchronous machine is one of the important types of electrical machines. So here if you observe in any electrical power stations, we are going to use electrical generators, that is a synchronous machine. So that's why it is known as an synchronous generator or alternator. So we have synchronous generator, this is also known as an alternator. Okay, so this is the introduction. So another topic in the introduction is mechanical and electrical degrees. So if we want to give the mechanical and electrical degrees for the synchronous generator, so we have to use the number of cycles and number of poles. So here the number of cycles depends on number of poles. That means, for example, if we take two-pole machine, okay, if we take two-pole machine, so that means we have one north pole and one south pole. So that is the two-pole machine, one north pole and one south pole. So here we are using one cycle. So here this one cycle is depend upon two-pole machine. So this is equal to the 360 electrical degrees. So two-pole machine one cycle is equal to 360 electrical degrees. And for example, if we take four-pole machine, so same cycle we are using, that is one cycle, but we are using four-pole machine. So it is doubling the previous one, that is 720 electrical degrees. 360 plus 360, 720 electrical degrees. That means in the previous we are used two-pole machine. So that is 360 electrical degrees. In this example I am using four-pole machine, that is one cycle, that is 720 electrical degrees. And if you want to take the 360 mechanical degrees into 720 electrical degrees, we have to use the formula, that is 360 into P, that is the number of poles, by 2 electrical. Okay, 360 into P by 2 electrical degrees. That means we have to convert the mechanical degrees into electrical degrees. That is 360 mechanical degrees into 720 electrical degrees. For that one I am taking this formula, that is here I am using theta m, that is the mechanical degrees. Theta m means mechanical degrees is equal to electrical degrees into P by 2. Here P means number of poles. Okay, here P means number of poles. Suppose I am using 360, I am convert 360 mechanical degrees into 720 electrical degrees. For that one I am taking theta e, that is the electrical degrees as 360 into P means number of poles. Here I am using poles, that is 2 or 4. Okay, so here we are using 700 degrees, we have to use 4-pole machine, that is 360 into 4 by 2 electrical degrees. Okay, this is the formula. So if you want to take theta m by theta 2 is equal to P by 2. If you convert this into this, that is theta m by theta e. So this one taking to this one, that is theta m by theta e, that is equal to P by 2. Okay. Next, frequency of induced EMF. So suppose we have number of poles, that is P, and speed in RPM, that is N, frequency is F, that is, so for one mechanical rotation of rotor, so that is equal to P by 2 cycles of EMF electrically, P by 2 cycles of EMF electrically. So then therefore P by 2 cycles per revolution, as speed is an RPM in 1 second, rotor will complete N by 60 revolution. So here we have the formula, that is frequency is equal to number of cycles per revolution, that is P by 2. Number of cycles per revolution, that is P by 2. Already we discussed it. This is for one mechanical rotation of rotor, P, that is equal to P by 2 cycles of EMF, that is number of cycles per revolution. Okay, here the revolutions is P by 2 cycles per revolution. So that's why P by 2 into N by 60, that is equal to N by 60 is the number of revolutions per second. N by 60, this is number of revolutions per second is N by 60, that is equal to P N by 120. So P by 2 into N by 60, that is P N by 120 hertz. This is the frequency of induced EMF. Okay. Next one in the introduction is synchronous speed. Next one in the introduction is synchronous speed. So for a fixed number of poles, alternator has to be rotated at a particular speed. So for a fixed number of poles of alternator, so that means we take 2-pole means we have to use 2 poles only. If you want to use 4 poles, we have to use the 4 poles. So that's why for a fixed number of poles, alternator has to be rotated at a particular speed to keep the frequency of generated EMF constant. Okay, at a particular speed to keep the frequency of the generated EMF constant at the required value. Such a speed is called synchronous speed. Okay, for a fixed number of poles, alternator has to be rotated at a particular speed. So first suppose we have to use the fixed number of poles for alternator for the rotation. So that's why we have to use the fixed number of poles, alternator has to be rotated at that time, alternator has to be rotated at a particular speed to keep the frequency of the generated EMF constant, to keep the frequency of the generated EMF constant at the required value. such a speed is called synchronous speed. So it is denoted by the letter is n suffix s. That is the synchronous speed notation. So we know that already we know the formula ns is equal to 120 f by p. 120 f by p already you know that in the previous subjects that is electrical machines and electrical machines too. You already studied this synchronous speed, that is ns is equal to 120 f by p. So actually in our country frequency is standard, that is 50 Hz. This is the standard frequency we are using in our country. Okay, the maximum value of synchronous speed of an alternator is 3000 rpm. This is the synchronous speed maximum value of an alternator, that is the 3000 rpm. Okay, so this is a synchronous speed concept. And so already I discussed about, I told to you DC generator is, it is used to convert the mechanical energy into electrical energy. Okay, that is DC generator. If you want to supply the DC supply means it is DC generator. So it is seen that in the case of DC generator, basically the nature of the induced EMF in the armature conductors is of alternating type. Okay, so here I am telling that a difference between DC generator and alternator. Okay, so in the DC generator, basically the nature of induced EMF in the armature conductors is alternating, that is AC type. So if we want to convert this alternating type into direct type, so we are using in the DC generator is commutator. So commutator is one of the part in the DC machine. So by using this commutator, I am going to convert alternating type into DC type. So that is why, so here I noticed one point, that is by using commutator and a brush assembly, so it is converted to DC. So here basically the nature of the induced EMF in the armature conductors is alternating type, but we have to convert this alternating type into DC. So for that purpose I am using commutator type in the DC generator. So here by using commutator I am going to convert DC and made available to the external circuit. So we have to convert the AC into DC by using commutator, and the converted DC supply is made available to the external circuit. Okay, so if the commutator is dropped from a DC generator and induced EMF is tapped from an armature directly outside, the nature of such EMF will be alternating. So if commutator is dropped from a DC generator, so previously I am using commutator in the DC generator, but in this one the commutator is dropped from the DC generator. So and induced EMF is tapped from an armature directly outside. So whenever the commutator is dropped from the DC generator, induced EMF is tapped from an armature directly outside, the nature of such EMF will be alternating. Okay, so the nature of such EMF will be alternating. Such a machine without a commutator providing an AC EMF to the external circuit is called an E alternator. So this is the difference between DC generator and alternator. So the difference is, so here I am telling that the difference between DC generator and alternator. So actually in the DC generator, the nature of the induced EMF in the armature conductors is alternating type. So at that condition I am using the commutator component. So this commutator is used to convert the alternating type into DC. So the converted DC is made available to the external circuit in the DC generator. But in the alternator we are not going to use the commutator. So we are not using the commutator. So here I am telling that if the commutator is dropped from a DC generator and induced EMF is tapped from an armature directly outside, the nature of such EMF will be alternating. Such a machine without a commutator. So same in the DC generator we are using commutator to convert the alternating type quantity into direct type quantity. But in the alternator we are not going to use the commutator component. So without using the commutator, we are called as that device is known as an alternator. So such a machine without a commutator providing an AC EMF to the external circuit is called an alternator. Okay, this is the difference between DC generator and alternator. Okay, so this is the introduction about the alternator, synchronous generator. Okay.